I am Danica Fine. I am a developer advocate at Confluence. I love to talk about Kafka generally. I spent a couple years building out very intense financial services, market data, Kafka Streams applications. And so in the process, learned everything that could possibly go wrong with Kafka and Kafka Connect. I built a couple connectors just for fun. It was mostly fun. I learned from my team a couple weeks ago that they finally sunsetted my connector. Like we didn't need it anymore. So that was fun. Anyway, so yeah, I love to talk about Kafka, and I love to be at these meetups. And today, I wanted to kind of piggyback off of vaguely what Kate was talking about in like operating and administering. So we're going to talk about something from the DevOpsy side of things. And I loved your quote earlier. I'm going to paraphrase here that everything will fail eventually. So we're going to keep riding that wave and talk about how to best prepare for these eventualities, right? Something is going to go wrong with Kafka. So what is Kafka doing to help mitigate that and make it as smooth as possible? And so with that, we're going to talk about HA and DR strategies with Kafka, sort of an intro, and then give you some actionable things that you start working with. So anyway, so first thing, are you serious? I confirmed that it was working, so okay. Anyway, no, the thing's right in front of me. I don't actually need the clicker. It's like an emotional support clicker, right? You just want to hold it. Anyway, so I hate abbreviations or this is an initialism, right? HA, yeah, initialisms. That's a new fun word if you didn't know it. So I just want to break it down because I feel like initialisms and acronyms and stuff are very alienating, especially in tech where we just toss them around for no reason at all. So I want to just break all this down. So HA, high availability. So in the whole overarching theme of how to make your Kafka more robust, HA is high availability, right? It defines an architectural strategy to create potentially redundant components of your infrastructure with the goal of minimizing or even eliminating any potential downtime across various areas of your system. So basically, and from the Kafka perspective, we want our data, we want our applications to be as available as consistently as possible, right? DR, we've got disaster recovery. So this is more of a, what are the people doing to eliminate these problems? So in the event that something disastrous occurs, we have some debilitating disaster scenario, like a major cloud outage, some common things these days. A DR strategy is going to outline the organizational steps that we are going to take to, again, restore service, minimize this downtime, and ensure that we're minimizing the disruption to our regular business operations. So obviously, HA, DR, they both sound like very, very good things. We want these. So what does this actually mean in the context of Kafka? Well, quite a lot. But how many of you are actually using Kafka right now? I want to do the show of hands. All right. How many of you are operating Kafka versus just building applications? So the rest of your application people. Wow. The hands slowly went up, which is very interesting. Like you had to think about it. Like, do I? Okay, so we're going to skip the basics of Kafka sort of things and bring people up to speed. So what is Kafka doing to help us with this whole HADR strategy? How are we making Kafka better and minimizing these disruptions? So Kafka's doing very much a lot, okay, as we're going to get into it from the high availability standpoint. Actually, a lot of this is actually built into Kafka for the high availability aspect of it. So if we go back to Kafka sort of basics. This is where it all comes into play, right? We've got our topic. We're breaking that down into components called partitions. You write your data in. They're going to be assigned to these different partitions and then stored across the Kafka cluster. Okay, so by breaking it up into these partitions, we are ensuring that, all right, if something disastrous happens, we're at least not losing all of our data. Right? So when we look at the Kafka cluster and we have, in this case, our simple cluster with 3 brokers, we've got 3 topics, some number of partitions or whatnot. So for topic A, we've got the data spread across these 3 partitions, which are as evenly distributed across the cluster as possible. Right? This is good for the downstream applications, right? So we can parallelize our processing, but it's also good for, this case of, okay, when something disastrous happens, right? We, spill coffee on some machine in the data center, right? Something disastrous is going to happen. Something is going to fail. In this case, we lose an entire broker, and that's a shame because we lost 1/3 of our data, right? But we only lost 1/3 of our data. We didn't lose all of it. It wasn't all on one machine, and that's silver lining, right? That's a good thing. But Kafka actually takes this a step further with the first high availability aspect. This is replication. So replication, built-in component of Kafka, it's a configurable parameter that defines how many copies of each partition we're going to have across our Kafka cluster. And if you were just building applications on Kafka, this is something that you might not necessarily think about, might be hidden or abstracted away from you, from whoever is operating your Kafka cluster. From your perspective, it might just be write the data in and get the data out, and hopefully it all works in the middle, right? But usually we have replication setup. A typical parameter is setting it to 3. So in this case, we're looking at that same 3-node cluster. We've got our one topic with our 3 partitions, and we have a replication factor of 3, okay? So now when we write our data to, say, partition 0, we are writing that data to our lead copy of that partition, okay, which in this case lives on broker 0. And then synchronously, we're going to copy that data over to the other replicas, the followers of that partition, which live on other brokers, okay? That's by design. We want that because now if that broker goes down, as it will, that sucks. We lost our lead replica for partition 0, but at least we've got 2 other copies of it elsewhere in the cluster, okay? So the cluster, when it realizes this broker is gone, we are going to do an election process. We're going to find one of those in-sync replicas and promote it to be the new leader, so our producers and consumers can keep operating with that, okay? So this replication process, this leader election process, this is already built into Kafka. So when it's set up properly, when it is enabled and you're using it, this is great for maintaining a highly available data across your cluster. So out of the box, that's pretty good. Kafka does, we use multiple brokers, we're distributing the data across it, and within the multiple partitions, and then we can synchronously replicate that data across our cluster. So within a single cluster, we, can ensure high availability of our data. But what if your entire cluster lives in the same data center? Then, I don't know, it floods. I used to work in New York and New Jersey, and our data centers were right along the Hudson River for some reason. And so they flooded once every couple of years. I don't know why they decided to put that there in the most expensive part of the US that floods all the time. But yeah, this was a big problem, is we need more data centers. We're not gonna move this one, but we need more to make sure that we don't hit this issue, that not all of our data is in one data center for this huge disaster scenario, okay? So how do we handle this, in this situation? So this is where we have to have a more robust disaster recovery plan in place to get around this, okay? The best way is to extend your Kafka clusters across multiple geographic locations, right? So the durability and the high availability we just saw within a single Kafka cluster, with the replication process, this is going to get even better. And then there's a lot of other disaster recovery options at your disposal at this point. And geo-replication is going to be really, really important for disaster recovery in Kafka. It's going to provide some of the best RPO and RTO numbers for across any DR strategy. And more initialisms. Yeah, because why not? Okay, so RPO, recovery point objective. So when this effectively defines if we're trying to move our data around between multiple locations for a disaster recovery scenario, RPO is going to define the frequency of our data backups. How quickly, how efficiently are we moving this data between these locations? So the event that the system goes down, basically how much data are we expected to lose between when the system fails and we come back online with whatever our backup option is. RTO is recovery time objective. So this effectively defines the amount of time that can be expected to pass between the point where the system left off before disaster strikes and the point where the system picks back up again when we failed over and we're resuming normal operations. So the event of any sort of disaster scenario, right, the entire data center catches fire and we would lose everything. Ideally, the best case scenario is we have an exact copy of our data somewhere else, right? We don't want to lose any data. So we want our RPO to be 0 in the ideal situation. And our RTO would just be, whatever amount of time it takes to flip that switch and fail over to whatever data store we have ready, okay? So the ideal situation. Let's try to reduce these numbers as far as possible. And Kafka is going to get us pretty good situation. So from the perspective of Kafka, to achieve georeplication, right, we first need to define clusters in multiple places, yeah, within or across different geographic regions. Cool, sounds good, pretty straightforward. But depending on your business use case and your requirements, what you actually need for your situation, there's a couple of options available to you. So let's look at some of these strategies a little bit more. So the first option is to create a single stretch cluster across multiple regions. So we saw the situation, or we described within the single cluster where all the brokers live in one geographic region, one data center. That's not very good. What we could do is we could spin up other brokers in completely different data centers, right? And still maintain a single Kafka cluster just with multiple brokers in different regions, okay? Because you're still using a single Kafka cluster, this provides the benefit of that synchronous replication process with the leader partitions and the replica partitions. You're gonna get better durability. You're gonna get the automatic failover. If one of the brokers with the lead partition goes down, we're just going to look for a replica elsewhere in the cluster, and hopefully, we find one up to date. And also an important thing and a really good benefit of using a single stretch cluster across these regions is that our offsets are going to be maintained. So for any of your consuming applications, when they're keeping track of where they've left off in their processing, well, if disaster strikes, I would like to still maintain those offsets, right? I would like to know that when we flip the switch and we bring back our other downstream applications, that they can pick back up from exactly where they left off in the processing. We want to minimize any disruptions here, right? So single stretch cluster, that sounds absolutely wonderful, but there are some limitations to this approach. In order for a single stretch cluster to actually be successful, the data centers can't be too far apart. So in the situation that I mentioned, we had data centers in New York that, on the river that were flooding a lot. Well, we decided to put the second one just 50 miles away in New Jersey, where it also kind of floods, but at different intervals. So that's how close the data centers needed to be in order to actually maintain the latency that we needed for our use cases. All right. So, is it that great? We did what we could. All right. So they can't be too far apart. You need to be able to maintain a stable, low latency between the two data centers, and you need a high bandwidth dedicated connection between them. Right. That said, it is worth mentioning that Confluent specifically, if you're using Confluent Kafka, we do provide the notion of observer brokers, observer nodes, to help loosen this requirement for the synchronous sort of replication. So in multi-region clusters, observers are going to asynchronously replicate data from lead partitions, from the leader brokers, allowing your data to eventually be consistent across the rest of the cluster without making it be a synchronous process that you need that low latency for, okay? So in addition, for a single stretch cluster, there's a little bit of overhead because you need to be a little strategic about where your replicas live, right? Because when you're spinning up brokers, if you let the Kafka cluster just deal with it without any additional configuration, it might be the case that your replicas end up in the same data center as the leader, right? And so that wouldn't be the ideal situation, again, because if that data center goes down, then, okay, all that work for nothing, right? So there is, I forget what version it was enabled in, but we can now make our Kafka, our brokers like rack aware effectively. So you can define specific regions so that we can say that our replicas are going to live within other regions of the cluster. Okay, so that is sort of built in. Okay. So if you don't want to deal with all that overhead, all that stuff to think about, maybe a multi-cluster setup would be more appealing to you. So in this case, you are going to set up fully standalone clusters in completely different geographic regions or cloud availability zones, and then you're going to have a separate process sit between them to actually do the replication process for you. Right? So in this case, you can choose completely different, continents if you wanted to maintain your data, your clusters in, maybe cheaper availability zones. You don't have to have it 50 miles away in a just as expensive area, right? So how you go about doing this, there's a couple different ways to actually do this replication process between these clusters. They're going to have different pros and cons. But before we get into that, I want to take a step back and I know we've been talking about high availability disaster recovery, but there's other business use cases for why you might want to set up a multi-region cluster. And I just wanted to explore those because it's not just for this redundancy and for disaster scenarios. There's other reasons why you might want to do this. So the first sort of setup structure for multi-cluster deployments would be an active-passive situation. So as the name implies, good name, we have one active cluster, we have one passive cluster, cool. The active cluster is the one where data is actively being produced to and consumed from. And then you'll have a passive cluster that the data is just being replicated over to. And if we do, again, have some sort of disaster situation where we need to switch over, we can start to use the passive cluster. But you can also use it in situations where, in times of peace, right? When things are operating as normal, but maybe this cluster is closer to some other consumers that can make use of that in a lower latency connection, all right? So, but mostly this is used, again, for sort of backup scenarios where you only need that passive cluster when something bad happens. The next is our active-active setup. Makes sense. We have two active clusters that we are actively producing data to and consuming data from. So we don't just have a single replication process here. We have two replication processes that are working to resolve the data from these two clusters independently. So this setup is really useful if you have, say a global operations in different geographic regions, different continents maybe, where data is actively being written to, and we have local applications that need to consume that data from there. But you also want all of the data across all of the clusters to eventually be resolved across, globally. Right, and be available to all the consumers everywhere for a lower latency. So I think you might have one of the clusters set up in EMEA, one of them in America, but you want that to be available to everybody eventually. Next, we have a fan-in setup. So here we have potentially smaller Kafka clusters that are going to be maintained in different geographic regions. Then we have many replication processes copying data from those smaller clusters to a single larger aggregate cluster. You can imagine that this might be, again, in like a cheaper availability zone or a cheaper data center. So you can maintain smaller, more cost-efficient data centers elsewhere or clusters elsewhere and aggregating it. But this is a good option to pursue when you want your local applications, local clients to be able to connect to and write to those regional clusters for lower latency, and then do any more intense stream processing or analysis later on after that data has been replicated to the central aggregate cluster. And then finally, we have fan out, which is effectively the opposite of that. So here we have a large central cluster that we're mostly writing to, and maybe reading from a little bit. And then we have many replication processes copying maybe a subset or maybe all of the data from that centralized cluster out to some of the regional clusters. Again, so that maybe local clients, closer to those clusters can get the best benefit of, more efficient pulls from the cluster for the smaller ones. Okay, so it's not just for disaster recovery scenarios. Sometimes it's just a little more strategic to set up multiple clusters. But back to the death scenario. So how do we actually replicate this data between these clusters? Because I kind of left that hand wavy and open, and you have options. So Kafka Connect is going to be one of the best ways to do this because you have a couple things built on top of it. So as we saw, great way to move data in and out of clusters, but also between clusters as well. I like to call these SOINC connectors because they're I'm still trying to push that term. I have like two people on board with me to officially create SOINC connectors. So they're combo source and sync connectors if you didn't get it. So we'd be using Kafka Connect to bridge the gap between the two Kafka clusters for the purposes of replicating this data. So depending on whatever distribution of Kafka you are working with, you're either going to use Mirror Maker for vanilla open source Kafka, or Replicator if you're working with Confluent Kafka to move the data between the clusters. So again, something to keep track of here is that consumers, when you're failing over, you want to make sure that your consumers know where they've left off. So it's really important that we keep track of our Kafka, our consumer offsets, when we are replicating this data, right? So in either case, the replicated data, when we move it over to the cluster, we might not have the same history in those clusters as we did on the initial cluster that we're moving data from. So the offsets that we're moving need to undergo offset translation, right? Offset 4 million in our original cluster might be, pointing to message 10 in whatever our destination cluster is. So we need to be able to translate that offset so our consumers are reading the correct data. So it can be seamless when we do that failover. So Mirror Maker and Replicator are great options for our multi-cluster setups. They're available for both our vanilla and our Confluent Kafka. They're flexible in how they're set up. But you do need to maintain, something to keep in mind is that you do need to maintain Kafka Connect. We saw some of the operational, what you need to think about to maintain Kafka Connect in that situation for the replication process. So that does introduce some overhead, but in a lot of cases, this is your best route to go. So now, if you are using Confluent, I wanted to mention that we've got Confluent cluster linking. So this is a built-in capability that mirrors not only your data and your topic configuration, your structure, your consumer offsets from one Confluent cluster to another. But unlike Mirror Maker and Replicator, this feature is built into the Confluent brokers. So if you're using Confluent, it's a good option to pursue. So there's no additional infrastructure for you to maintain or Kafka connectors, and you can pretty easily and quickly start up and replicate your data. So there's a couple other cool features that are built in. So it is byte-for-byte replication between the two clusters into what do we call mirror topics. So these mirrors are going to maintain the exact offsets. So there's no offset translation that your clusters have to undergo. So it's going to be a very seamless transition there. Building on the byte-for-byte replication, the mirror topics are completely read-only until there is some sort of disaster scenario where you have to read that data from it and start writing to it. So you can ensure the integrity of whatever data ends up on your destination cluster. And yeah, you can also set up your access control lists. Those are going to be mirrored over. You can mirror all of your schemas as well. So it's again, just a good thing to check into if you are using Confluent Cloud. So that was the very, very quick primer on high availability disaster recovery with Kafka, some of your options. So if you're curious to hear more about this subject, I included a link to my link tree, and there is a very, very thorough set of resources toward the bottom on like stretch clusters and multi-geographic regions when we're setting up Kafka clusters. So I encourage you to check it out if you're curious to hear more. And I've got another bunch of other random resources on there as well if you want to take a look on what I've been working on and what the folks on my team are working on course-wise. So yeah, I do believe I tried to go a little quick because I wanted to make sure we weren't going over, but we do have time for some questions. So thank you. I'm sorry, my clicker didn't work. I feel like it ruined everything.
So you talked about
Yeah.
offset translation. So is it like a manual process for the top three options? Like we have to write a separate process that is doing offset translation?
No, it happens as part of the replication process, but it's just another thing that is occurring as part of it, and another thing that could potentially go wrong because the data isn't exactly the same in the two clusters. I haven't heard of any horror stories where it's gone wrong. I don't know if you have either, but
no, so
just something to keep in mind.
If you're using Mirror Maker, it's worth being aware. So Mirror Maker basically works as there's multiple different Mirror Maker connectors that you can run. So you have to run the offset, I can't remember what it's called, the specific connector that you run. But there's like the source connector which does the actual data, and then if you're running Mirror Maker, you have to make sure you enable the connector that's going to translate the offsets apart. I don't know how it works in Replicator.
I do not.
Similar.
No, I think it is really similar though, but yeah. Just another thing to know that it happens.
It's enabled by default.
Yeah. Yes?
If I wanted to go home tonight and set up a Kafka cluster on my Kubernetes cluster at home, say for example, what would it look like from, say, would it be like a pod for every broker or a pod for every topic? How does that really look like if I wanted to set up, see like tonight, for example, just like practically?
Yeah, just a regular Wednesday night. Yeah. Yes. So I would be just spinning up some Kafka clusters. Yes. So the typical way is, a pod per broker. And so, yeah, if you want to test some disaster recovery scenarios, you'd set up, I'd say, like a six brokers and have, or I don't know, that's overkill just for playing around with it. Maybe just 2 brokers and have them different regions or something. I'm sorry?
Plus some Zookeeper.
Yeah, just go wild. But yeah, it's broker per pod.
Does the Zookeeper act like the master node, the way like we see if we like compare it to like Kubernetes, for example? See how you have like the master and slave nodes? Is it similar kind of?
I don't know how it plays on the.
So you can think of Zookeeper as basically Zookeeper is where Kafka's storing metadata. So you're basically just running something else where you're going to store metadata, and Zookeeper as a piece of technology is also clustered, so you also run multiple of them. If you run in craft mode though, which is the kind of new way moving away from Zookeeper, then instead of having Zookeeper nodes where you're storing your metadata, you have other Kafka nodes which are called controllers. And again, you can run a single controller, or if you want to be more sort of highly available, then you would run multiple of them. And similarly to the brokers, they would be individual pods.
Right.
So you'd have like some controller pods and some broker pods.
And when you say metadata, you're talking about like the suspense topics and the like.
So it stores things like what topics have been created, and I don't know if anybody else knows off the top of their head what.
Leader, like who's the leader for the partition?
Yeah.
So it'll store what the leader is.
Yeah.
How many seals, like how many partitions, how many replication factor.
The controller.
All the metadata.
So there's a couple. If you took the link tree, it's still up. On Confluent Developer, we have a lot of tutorials on how to spin up a craft mode in containers. So you can check it out. That'll be a lot easier than Broker. Yeah.
We have this is quite interesting actually, just mentioned Zookeeper, because I just looked at the reference on the book he gave me, and it was still references by Confluent to Zookeeper. We know that Zookeeper is deprecated by Confluent. We have existing clients all over the world, all over the globe. They're still running Kafka and Zookeeper. My question is, how long is it going to be supported for?
It's marked deprecated. 4.0 is going to be out. Right.
Yes. So when Kafka version 4 lands, at that point you will have to be running in craft mode. That's my understanding, right?
Yeah.
But I know that 3.7 came out, and then I think is 3.8 out already?
Yes.
3.8 is not out yet. No.
You are a Kafka person.
Soon.
So the 3 dot versions of Kafka, they've been basically trying to get to a point where it's like feature comparable. So Zookeeper was kind of deprecated when we weren't quite at the point yet where everyone could migrate, because there were some features that just they hadn't quite got around to putting them in craft mode. So the aim is basically when they move to 4, that's them saying like, right, everything has been moved now, you should. So there'll be like, I think 3.8's, I guess, the last version.
Hopefully.
You can migrate to craft mode on 3.8, and then when you move to 4, then Zookeeper is no longer possible. But it was definitely the case of like, it was deprecated, but not everybody could move yet, so that's why it's taken a while for it to be fully removed, because there were some features that were missing, basically.
But if you were starting new clusters, it was like safe to start in craft mode by like 3.5 or 3.6, right?
There were certain existing features that you wouldn't have been able to keep using until they were added. So, but yeah, whenever 4's coming out, I don't know.
It's the underscore final.
The 3.8 is July, August.
3.8's July, August. Yeah.
Hopefully. The last couple of releases have been late. So, which is good, we're making sure things are great before they go out. But yeah, 4.0 is like the underscore final. We mean it this time. And I feel like every release, there's so many KIPs that address like a little bit of a tiny gap between Zookeeper mode and craft mode. And now it's like this plush suite of fun features and like ways to migrate over slowly and revert back just in case. And it's great. It's been great.
Well, initially, we did it with a client who's a major bank, not far away from here actually. We moved on and we had to roll back.
Mm-hmm.
Waiting for new announcements from Confluent.
Well, it's not just Confluent. So it's this is being driven by the open source community. So it's not necessarily Confluent, but you're using Confluent, or
They're using Confluent.
Okay, I want to separate those two things for everybody here. is that Confluent was pushing for new clusters in cloud to be craft mode, months and months and months ago. So yeah, it's different from what people are necessarily doing in open source.
Yeah, it depends on how you're running it, right? Because if you're a cloud offering, you kind of get to decide how you deploy it. Whereas if you're, like, we have customers who are running Kafka using our tooling, but they're running it and managing it themselves. So we can't, like, knock on their door.
Or else.
And make sure that they're supported in their migration process. But it's harder for us to kind of force them down the road until the point where they can't update anymore.
Yeah.
And once the Kafka open source project go, like, this version doesn't work, we're not going to add support back in. Like, alright,
The initial proof of concept years ago was the Apache Kafka. They liked it so much. They needed more functionality that moved them off the Apache Kafka, and they moved into Confluent, which gave them extra functionality, security, and so on across the board. Now the issue now is they're not quite sure, especially when the announcement was made of the replication of Zookeeper. That brought a lot of confusion. Confluent never gave this definite date as to when they will stop supporting installations made on Zookeeper. And banks want certainty.
yeah.
Instruction.
I guess that's the tricky thing of both Confluent and all of the companies that use Kafka. Like, they don't know the dates because it's decided by the open source community ultimately. So it wasn't necessarily that Confluent wouldn't put like a line in the sand. It was that actually Confluent are having to wait for the open source community to put the line in the sand, and then everyone else goes, oh, okay, there's.
Oh, there it is. We knew it was going to be right there. Yeah. So yeah, next year. Next year. Yeah.
You were saying about stretch clusters needing low latency.
Yes.
How low is low?
Oh man, I'm telling you that I don't remember the exact numbers, but the New York to New Jersey was almost not good enough.
And what happens if it's not low enough? Does it break? Does it keep going? But
it was just tough for us because, again, this is market data, and so if there were going to be any sort of disaster situation and that data wasn't actually replicated over, I mean, I think it was under a second or two, but it was still like we operate on milliseconds with financial data, and so losing a full second worth of trades is like, okay, that sucks. But like for a lot of use cases, that might be completely fine, right? You really have to assess what stretch cluster means for you, and if that's good enough. If multiple seconds.
Something like that. Like for financial data, probably like 200 milliseconds. It's like the max you want to run, otherwise you'll get consumer lag, which isn't a lot.
Yeah. But so Kafka would still function, but just consumers would be.
It would still function, but just in the situation where like you do need to fail over, imagine how much you're potentially losing that's relevant to your use case as well.
Follow replicas will be out of sync as well.
Yeah.
So in case of the data goes down, so your follower is not up to date. So you potentially lost some data as well. Like if you lose complete data on the leader, so that is also a possibility.
Okay, thanks.
Yeah.
I think that's it.
Yeah.
Yeah.
Thank you all.
Yeah.